In the first part of lesson 6.1, we learned how to add two functions together. So on number 1, we're going to do the same thing, but then we're also going to plug in 2 for x. So there are two ways to do this problem. You could add the functions together first, like we did in the last lesson. So if I'm adding 2x plus 3 and x minus 5, that would make 3x minus 2. And then I take my answer and I plug in 2 for x. So if I do that, I get 6 minus 2, which is 4. So that was adding f of x and g of x together and then plugging in 2. Your other option is plug in 2 first to each of them and then add them together. So if I plug in 2 here, f of 2 would be, we could do that mentally, 2 times 2 is 4, plus 3 makes 7. And then if I plug in 2 here, g of 2 would be 2 minus 5, or negative 3. And then I just take the two answers and I add them together. So both ways I do this problem, I get 4. So you can add them together first and then plug in 2, or you can plug in 2 to each of them and then add those answers together. Okay, for number 2, you're going to multiply f and g together. So again, you have two options. You could FOIL out f of x and g of x, or it would probably be easier if you just plug them in separately. So f of negative 1 would be 2 times negative 1 plus 3, which would be negative 2 plus 3, which is 1. And then g of negative 1 would be negative 1 minus 5, which is negative 6. And then I just take those two answers. And I'm not going to add them this time because this one's multiplying. So I'm going to multiply my two answers. 1 times negative 6 is negative 6. Okay, the next thing we're going to learn is a composition. So if you look at the symbol, that open circle, that's not multiplying, that means composition. So the way I read this is f compose g of x. And all that means is you're going to take g of x and plug it into f of x. So instead of f of x, I'm going to plug in g of x where the x usually is. So g of x is taking the spot of x in the f equation. And so for the one underneath, this is g compose f of x. So normally we would write g of x, but f of x is taking the spot of x in g of x. Alright, it's a lot easier if you actually have an expression. So for this example, I want to take, so for f compose g, you start with g and you plug this in for x. So f compose g is going to be 3, and then instead of x, I plug in x minus 2. So g of x gets plugged in for the x in the f function. And if I simplify that, I get 3x minus 6. Alright, so now we're doing it the other way around. For g compose f, you're going to take the f and you're going to plug it in there to that x. So 3x takes x's spot, and then you still have the minus 2. Alright, so let me draw a model of that. So if I want f compose g, again, you start with g of x. So g of x was x minus 2. So I start with x minus 2, and then we have f of x is 3x. And so the g of x expression gets plugged in to that x. And we have 3 times x minus 2, which is 3x minus 6. And that's what we got earlier. So for g composed f of x, you start with f of x, which is 3x. G of x is x minus 2. So for this one, f of x gets plugged into the x for the g equation. So that becomes 3x minus 2. Alright, it's very different when you have coordinates for the function. Alright, so the way this works, we're going to do f composed g first. So if I want to find f composed g of x, first thing I do, I start with the second letter. So I start with g. So the first coordinate in g is 4, 3. So notice I started with 4, then the y was 3. So then the next thing I do is I try to match the y coordinate from g with the x coordinate from f. So the 3 over here magically teleports us over here, and then we end up at negative 2. So if you were following along, we started at 4, this 4 here, then that took us to this 3, which teleports us to the other 3, and then we ended up at negative 2. Okay, let's try that again with the next coordinate. So it's 2, which takes us to negative 1 here. Then we look for a negative 1 in the x's on the other side, and that takes us to negative 5 at the end. Okay, so what number did we start at? We started at 2. 2 took us to negative 1. Negative 1 took us to the other negative 1. Then we ended up at negative 5. Okay, for the next one, we have 9, which takes us to 4. Now we look for a 4 in the x for the f equation. Takes us there, and then we end up at 7. So we started at 9 and ended up at 7, so the coordinate is 9, 7. Okay, for the last one, start at 3, takes us to 10, teleports us to that 10, and we end up at 8. So the last coordinate would be 3, 8. And close the braces. So that's f composed g of x. They also want the domain and range for each. So the domain is just the x values. So if I list out the x values, it looks like 4, 2, 9, and 3. I'm going to put those in order from least to greatest. So 2, 3, 4, and 9. So because it's not an equation, because it's just coordinates, I could list out all the possible x values. If it was an equation, I can't list them out because there's infinitely many. Okay, for the range, that's just all the possible y values. So I see negative 2, negative 5, 7, and 8. Putting them in order, the smallest y value was negative 5, then negative 2, and then 7, and then 8. Alright, now we need to find G compose F. So G and then the circle means compose G compose F of X. Okay, so we look at the first coordinate in F. So you always start with the second letter in the composition. So we look at the first coordinate in F. It is 3, -2. Then we look for a -2 in the X for the G coordinates. There is no -2, so that one doesn't work. So we go to the next coordinate, -1, -5. So now I'm looking for a -5 in these X's, and I don't find one. So I tried the next one, 4, 7. So I'm looking for an X that is 7, and we don't have that either. So we try 10, 8. There's no 8 in the X's over here. So G compose F of X does not exist. We can say that it is undefined. Okay, so on the back we're going to compose two equations again, and then we're going to find the domain and range of the composition. So first let's find F compose G. So remember, you start with the second letter, which is G. You're going to take X minus 2, and you're going to plug that in right there. So take G and plug it into the X for the F of X equation. So this one is the F compose G. So I replace this X with X minus 2. So then there's a square outside and a plus 1 afterwards. So if I FOIL that out, so a common mistake here is people think it's x squared plus 4 because they forget to FOIL. So if you FOIL x minus 2 times x minus 2, you get x squared minus 2x minus 2x again, so that makes minus 4x, and then a plus 4. Then we still have the plus 1 on the outside. So now I distribute the 3x squared minus 12x. 3 times 4 makes 12, and I'm going to add the 1 on the outside. 12 plus 1 is 13. Alright, so this is F compose G of X. They also want the domain and range. We learned that the domain can be pretty much everything except whatever makes the denominator 0. There is no denominator for that expression. So x can be any real number. Alright, the range. We learned very recently that if the degree is odd, one end will go up and one end will go down. But this degree is even. So when one end goes up and one end goes down, your range is all real numbers. But when your degree is even, it's not all real numbers. Alright, the degree specifically is 2. When the degree is 2, we know that makes a parabola. I know this parabola opens up because the leading coefficient is positive. It's positive 3. So because it opens up, it has a minimum. So we know that the range is going to be y is greater than or equal to, and we have to figure out what that minimum value is. So recall that the minimum value is the y coordinate of the vertex. The x coordinate of the vertex is negative b over 2a. So if we do negative b over 2a, b is negative 12. So negative b is positive 12, and then 2 times a is 2 times 3, which is 6. So negative b over 2a equals 2. And so if we plug in 2 for x, we get 3 times 2 squared is 4 minus 12 times 2 would make 24 plus 13. This all equals positive 1. So the range is y is greater than or equal to positive 1. Okay, so now we have to find G compose f of x. Alright, so for G compose f of x, remember you start with the second letter, so we're going to take 3x squared plus 1, and we're going to plug that in to the g of x function. So this, which is f, gets plugged in right there. So that's going to become 3, and let me label that this is G compose f of x. So x gets replaced by 3x squared plus 1, and then minus 2 is still there. So final answer here is 3x squared. 1 minus 2 is negative 1. And now we just have to find the domain and range there. So the domain, there's no denominator. So the range, or the domain is all real numbers. The range, alright, if you do negative b over 2a, you get 0 because there is no b value. The reason there is no b value, b is what is in front of x to the first, and we don't have an x to the first term, so b is 0. So negative b is also 0. 0 divided by 6 is 0. So if you plug in 0, you get negative 1. So we know the vertex is 0, negative 1. For the range, all we care about is the y. And we know this one also opens up. So it's going to be y is greater than or equal to negative 1. Alright. So as you can see in the last problem, it's a lot of work to plug in one function into another. It's actually a lot easier if you're given a number to plug in instead of just having an x right there. So the shortcut for this one is to work backwards. Take negative 2, plug it into the g of x equation. So first thing I'm going to do, I'm going to plug in a negative 2. So if I plug in negative 2 to the g of x function, I get positive 2. Now I'm going to take this 2 and plug it into the next letter, working backwards. So now I'm going to find g of positive 2. So that one equals 6. And now I'm going to take this answer and plug it into the first letter. So we have to find f of 6. So final answer is 18. So working your way backwards, plug in negative 2 to this equation. Whatever answer you get, plug it into this equation, which is g again. Then whatever answer you get there, plug it into that equation. Looks like we never use the h of x equation. So for this last example, you're trying to make a profit by selling coffee mugs. When you sell stuff, your profit is how much you sold it for minus how much you bought it for. So in other words, profit equals how much you sold it for, which is also known as revenue, minus how much you bought it for, which is the cost of the item, or in this case, the cost of making the item. Okay, so P of X, this is our profit function, equals, we have to take the revenue function and subtract the cost function. And I want to subtract both of these, so I'm going to put parentheses and then distribute the negative. Okay, so this is our P of X function. 6.5x minus 0.75x is 5.75x minus 1,850. Okay, that's the first thing they asked for. Second thing they asked for is the profit for 1,000 coffee mugs. So we're going to plug in 1,000 for x. $5.75 times 1,000 is 5,750. Subtracting 1,850, we have our final answer, which is $3,900.